All right, so can you guys see the record button in the upper left-hand corner?
Yeah.
Okay, and then you can see my blank white sheet of paper as well.
Yeah.
All right, okay, so I think it's gonna work. All right, so I have my last 3x5 right here. And this is that's the front. Notice my pen was dying, so there you go. So there is the front of my 3x5, and here is the back of my 3x5. Okay, and if you recall, this gets us to question 80, which is the last question on the final. And then what I'm going to do is we will have kind of an open mic thing where I would like you to go back through all my 3x5s and ask questions on whatever those topics are you think you might need help with. Because if I covered it on my 3x5, it is directly on the test. Okay? So just kind of go to that point. We'll see what happens. Remember, the final, we've decided, well, let me write this down. So it is 5-4 today, Star Wars Day. 5-4, and this is going to be Chem. 11-10. Cumulative review. Technically, this is day 4. All righty, so just a couple of things. Final will be on Friday, 5:15 at 9:30 a.m. And it will end at, did we decide 2.5 hours?
Till 12.
Yes, that's why we went a little early. So we're going to go, and it will end at 12 noon. And this is no exceptions. Okay, so that'll get it out of the way, yada, yada, yada. Gives us plenty of time. Last day, as far as, stuff I'm going to push. And then we'll just have some days to kind of clean things up. All righty. So you got to know what O, M, and P positioning mean. Positioning. Who knows what I'm talking about?
Not like ortho, meta, and para.
So I got ortho, I got meta, and I got para. Was that Tolman? Is that a Tolman?
Yes.
What do they mean? And remember?
Is ortho next to meta is like one space apart, and para is exactly opposite.
Right, and that's all with references to where it is on the benzene ring, right?
Yeah.
So those two would be O, right? Ortho, they're right next to each other, right? Okay, and then if I was here, it would be meta would be there, right? And then obviously P would be there. Ortho, meta, para. That makes sense?
Yes.
All righty. Now, is Aaron Hawes on here? No, Aaron?
Yeah,
All righty.
Yeah,
I believe this was your question the other day. I don't think we talked about it as a class. I think this was just a you and me thing. But if I take a benzene and I add H2SO4 and nitric acid, this right here, this is my catalyst. Does anybody know what will happen here? So if I take a benzene, and I add this to it, do you remember what happened there? I thought this.
No, I'm not sure.
No, this is the one that gave me SO3H. Didn't you ask me this in an email one day?
Okay, yeah, I remember that one.
There was a question. There's a question on the homework that talks about this, and it's funny. But at the end of the final, even though they asked you some questions from this chapter at the first, they added a couple more at the end, as far as the true final went. So this is when I take a benzene ring and I add sulfuric acid and nitric acid to it, I'm gonna sulfonate. I'm gonna sulfonate this. And I want to say it might have been Butler that asked me about sulfonation the other day. And this is kind of like that. Was that you, Butler? I thought I saw you on here. Do you remember that?
I don't remember that.
You don't remember that? Okay, it might have been somebody else. But anyway, that's what goes on there. Okay. And then in that same vein, a question I know I talked about the other day is, anybody know how I go from benzene to chlorobenzene? I believe that was this class. It might have been Hudman. Is Hudman on here? Nobody?
So isn't it benzene plus Cl2, and then the arrow, and then over the arrow is the catalyst, which is the FeCl3.
Just
And
like
then,
that.
And then you'll only replace one of the H's on the benzene ring with the Cl.
Like that?
Yeah.
That's chlorobenzene? Yep. What would be one of my byproducts here, Tolman, now that you bring it up? What else would be here? I don't think they even address it, but do you remember what I talked about?
HCl.
Yeah, good job. Is that you, Butler?
Yuri,
nice job. Okay. Does that make sense? And I know, I thought it was Hudman that asked about this the other day, but that's the question. Okay. All righty. Some easy stuff that I do think they bring up is there is some dimensional analysis. Anybody remember what dimensional analysis was?
like setting up your equation to get rid of the units that you don't want, and then.
Okay, so basically changing units. I know way back we did, like we went from, inches to miles or something like that, right? So there's something like that. There's a dimensional analysis question, but it's really straightforward, okay? There's also a question about atomic size. Now, we never memorized any of this stuff, but if I'm looking at the periodic table, does anybody remember the trend in the periodic table of where the size was at? Where were the biggest, where were the smallest?
It was the most down and the most to the left.
Down and to the left. So this size was what?
Biggest.
These are the biggest. Okay, so where's the smallest at then, Sierra?
It's the highest and most to the right.
Okay. So atomic size has a lot. I mean, it's very similar to, what was the other one? Electronegativity, right? Just the backwards of it. These ones had the highest electronegativity and those had the lowest electronegativity. And atomic size was just opposite of that, wasn't it? Anybody remember that? I mean, that's been a long time ago, but I do remember teaching that. Okay. All right. Now, the next thing is this. If I gave you COCl and I gave you COCl2, okay, and I asked you to name these, anybody know the difference if I were to name those two, what they'd be?
one would have a dye in front of the chlorine.
Would it? Would one have a dye? Nobody? Not one person.
It wouldn't have a dye because it's a cobalt in the front.
Okay, so what do you mean by
So
that?
it'd have a Roman numeral.
Ah, why would I have a Roman numerals? That you, Thompson?
Yeah.
Why would I have a Roman numeral?
I can't remember.
Because it's a metal to a non-metal.
A metal to a non-metal, which means it's what kind of bond?
Covalent? Question mark?
Nope.
Ionic.
Ionic, right?
There we go.
Now, when we did this, we talked about two different types of ionic compounds. We had type 1 and we had type 2. Anybody remember the difference? Nobody? I'll give you a hint. Type 1 was when I had a representative metal bonded to a non-metal, and it did not require a Roman numeral. And then I had type 2 that did require a Roman numeral, and that was when I bonded a what?
A transitional metal with a non-metal.
A transition metal with a non-metal. And why does a transition metal typically, not always, but typically require a Roman numeral?
Because
Anybody remember?
it has different charges sometimes.
Yeah, it has more than one oxidation state. So this one would be cobalt 1 chloride. This one would have been cobalt what? Anybody know?
2.
2. Why?
Because of the 2.
Yeah, but do you remember why that was? Remember that 2 is the what? It's not how many there are. It is the what on that cobalt.
Charge.
The charge, right? So what I would have had, I would have had this, then I would have had Cl2, right? Well, what's the charge on each Cl? Anybody remember what chlorine wants to be?
-1.
Wants to be a -1, right? And if I got 2 of them, that gives me a net 2 negative, right? That means my cobalt must be a 2 positive. There's only one of them. That gave me cobalt 2 chloride. Okay. From there, there is a question about adding in lone pairs. I know I did this on my board one day. This was a question maybe 2 tests ago where I kept harping on how to tell how something bonded right. And we said you got to make sure you add in the lone pairs to determine what. Does anybody remember what it was? Why we added in the lone pairs, what it helped us determine?
The three-dimensional state.
It helped us, the three-dimensional state, and then one other thing. Somebody said it, I thought.
Arrangement.
If it's polar or non-polar.
Polar, non-polar, right? So all those electrons gave me negatives, right? But you were right. Whoever said arrangement, that also was part of that. You're right. Help me determine arrangement and shape and then polarity. All 3 of those. So what they do is, does anybody remember the one I drew on my board when we did this? It was something like, they gave you something like this. Something like this, and then we had all these H's, right? And then what do we have to go back and realize here? Anybody remember? I know we covered this, and it's not been that long ago. Anybody?
Oxygen will have lone pairs.
Yeah, oxygen's got 2 sets of lone pairs because oxygen only likes to form 2 bonds, right? And those 2 lone pairs would make this area kind of negative, make the other end kind of positive, which would create a polar molecule. Nobody besides Sierra remembers that?
I do.
Okay. All righty. So couple of artwork questions. Now, when I say artwork, do you know what I mean? Nobody?
Lewis structures?
Well, you know how they do those pictures with the circles with the little things in them? You know what I'm talking about?
Oh, yeah.
Yes, like what is this? Like if I gave you this, if I gave you A plus 2B yields C, and I did this, and I asked you which letter is the limiting reactant. Can anybody answer that question?
Isn't it B, because for every A you need 2 B's?
Okay, so I've got 1, 2, 3, 4, 5, 6 A's, right? Well, if I have 6 A's, how many B's do I need?
12.
Yeah, I would need 12 B's, right? But I only have what?
6.
I only have 6, so B's my limiting. A would be considered what? You remember what we called A? Popular 80s band? Not so. It would be considered in. Nobody ever remembers me saying in excess? Not a soul.
I do.
You do, and then there was a band back in the 80s called In Excess. That was their band name. This is the band. Go look them up. They had a couple of good tunes. Had one song called Suicidal Blonde. It was pretty good. Okay. All righty. They have one other artwork question in it. It is a K equation. Okay. It's a K equation. This is also an artwork question. Okay. And it was something like this. It's like, let's say I've got A plus B yields C, right? And this is at equilibrium. At equilibrium, this is what I've got. Okay, and the question is K high or is K low? Anybody remember what the K equation looked like?
Isn't that moles of A, like the concentration of A to the concentration of B to over concentration of C? It's something like that. It's like concentration of products over reactants.
Okay, so if it's products over reactants, what's wrong with what you said?
I did reactants over products.
Yeah, so it would have looked like this, C over A times B, right? Correct?
Yeah. Yeah.
Most of that, there's a lot more of what in there? What's represented the most?
Product.
Yeah, there's more products, right? So there's more products. This would favor the what? It would favor the products, and that would give me a K that was higher than what? What was our magic number there? Anybody remember?
Wasn't it 1?
Yeah. So my K would be bigger than 1, wouldn't it? And if you look at it, I'd have 1, 2, 3, 4, 5, 6, 7, 8. I would have 8 over, what's that? 3 times 2? Which would give me 8 over 6, which is bigger than 1, correct?
Yes.
Yes.
All righty. Okay. So that's that. Now, this next question is verbatim off of the chapter test we took. And it has to do with this. It says, at STP, which cylinder contains the greatest number of gas particles? Okay, now, and then they give you 4 cylinders. What do I have to do there? Anybody remember?
See which one has the most volume.
See which one has the most volume, right? Because whichever one has the most. Okay, but what if they all had the same volume? Anybody remember what we did here?
Look at pressure.
Is it atomic mass?
It was atomic mass, right? Because we're at STP. So we're at the same temperature and pressure, right? And Tolman mentioned volume. You're right. The volume was different it'd have, but if they had the same volume, we went with the one that was the what? The smallest mass, I believe. I don't know who said that, but isn't that what we did there? Because the one that has the smallest mass is going to have the greatest number of particles, isn't it?
Yeah,
Was that Aaron? Who answered that question?
it was me,
Sorry.
Connor Buxton.
Oh, Buxton, how's it going?
Good.
You at work?
Yeah.
Yeah. Your little brother the other day was on at work. I thought it was funny. That's a good boss right there, but I guess when it's your dad, it's okay, right?
Yeah.
Yeah. Okay. So yeah, we went with smallest mass. And then the next question, well, for me, it won't be for you, is very similar. It said, which solution contains the smallest number of particles? Okay. Now this one is quite different. I don't remember. I know we did one like this when we took the real test. On this one, you actually just must calculate. Must calculate. Okay. And it's going to give you 4 solutions. You just got to go and figure out which one has the fewest particles in it. You know, like if they were all molarities, I would just pick the one that has the what molarity, highest or lowest. Anybody know?
Highest.
Is it the lowest?
I'm hearing both. What is molarity? Who remembers
It's the concentration.
Okay, but what are the what's the units there? It is moles over liters,
volume.
right?
Oh yeah.
So if I have a high molarity, that means I've got a whole bunch of moles, right?
Yeah.
If I have a whole bunch of moles, that means I've got a large number of particles, don't I? So if they were all molarity, I would want the one with the smallest, wouldn't I?
Yeah.
Okay. All righty. Then from there, gosh dang it. Lose my. Guess I got to start dancing around the classroom more. All righty. Then from there, there is a titration equation. A titration equation. When we did these, I taught you an easy way to do it. Anybody remember? Anybody remember the easy way we did titration equations? Nobody? Well, let's look at it. Let's say I gave you HCl plus NaOH yields H2O plus NaCl, right? And I said, how many milliliters let's say I go of 2.4 molar NaOH are needed to neutralize 77.2 milliliters of 1.6 molar HCl. Anybody remember how to do this? Not one of the 67 of you, actually 65 of you remember this? Coleman? Nothing? Tolman, you don't remember this?
Give me a second here.
How about Treo? You on here, Jace?
Would you have to find out how many moles there are of NaCl, and then for every mole of NaCl, it's going to neutralize 1 mole of NaOH?
Okay, and that was the long way to do it, Sierra.
Well,
100%.
it's one way.
You're right. I could do that. But does anybody remember the easy way I taught you to do these? Although you could go Sierra's route, 100% correct. But I taught you an easier way.
Don't you just set up an equation and solve for x?
Kind of, but you remember how we did that? We've used it a couple of different times in a couple of different ways.
Is it the M1V1 thing?
Yeah, we went M1 V1 equals M2 V2. There's only one thing I had to watch out for. Does anybody remember?
Different units.
Nope.
Was this one where you had to times it by 2 or something?
Exactly. This is it. Okay, but do I need to times this one by 2?
No.
Why not?
Because you have like 1H in each one.
Yeah, because this was called monoprotic. This is monobasic. They're both one. This just straight up this. So I would literally go, 1.6 molar times 77.2 milliliters equals 2.4 molar times V2. Divide by 2.4 molar, divide by 2.4 molar, gone. V2 is, anybody got the math on that?
51.
51 milliliters. Does that make sense?
No. Yep.
Anybody know how to look at that and know if it makes sense? And remember how I can look at that problem and determine whether or not I can or cannot be right?
You can plug it back in.
I could, you're right.
So you look at the molar difference. So the NaOH is 2.4 and the HCl is 1.6. And so if the 2.4 is higher than the 1.6, then your whatever you call it, volume of your HCl or your NaOH has to be less than your volume of your HCl.
Okay, does anybody know what the word we used for that was? They have a something. Nobody?
Inverse relation.
Nice job. They have an inverse relation, right, Ireland?
Yep.
So because this one has a higher molarity than that one, that means I'm going to need what? If my molarity goes up, my volume's got to go where?
Up.
My volume goes up?
Goes
No,
down.
your molarity goes up.
Molarity goes down because they're inversely related. Okay. All righty. There is a fission equation. We did really well on this stuff on that test. So I'm not going to harp on that. What's the one thing that has to happen in fission? Anybody remember what has to happen in fission?
Something has to collide with the reactant.
Okay, so I'm going to take my reactant and I'm gonna hit it with what usually went here. Do you remember?
Was it an electron?
Nope.
A neutron.
A neutron. I bombard this by a neutron. But what did I always get out here?
2.
I got to have 2. I went that plus that, and then I usually had some more what?
Gamma or neutrons.
Well, yeah, some more neutrons or something else there, right? You know, maybe 2 of those. And then what did they do here? Anybody remember what they did here usually?
They'd give you like
they gave us one of these and had us find the other one, and that's exactly what they do on the test. They're going to give you some radioactive substance. They're going to bombard it, and it's going to split, because that's what fission does, is it splits into 2 things plus some more radiation. And they're going to give you one of these. They're going to expect you to find the other. Okay? All righty. Boiling point. So boiling point. How does boiling point apply or correspond to surface area? Anybody remember how boiling point and surface area are related?
It all depended on branches, right?
Okay, so what did we talk about here? So if I have a high or low surface area, so if I have a high surface area, what does that do to my boiling point? Boiling point go up or down?
Up.
Up, right? And a high surface area corresponded to fewer, I don't know who that was, but fewer what?
Branches.
Fewer branches. Okay, the fewer amount of branches I have, the higher my surface area, the higher my boiling point. Okay. And then the last thing they talk about is functional groups, but I think I mentioned these the other day, didn't I? Didn't I mention functional groups the other day on one of my other note cards?
Yeah.
Yeah, so I've got, let me see here. Yeah, it's on the front side of day 2's note card. That's those 2 lists on 403 and 405, which means that there's at least 2 questions that relate to those 2 tables of being like a carboxylic acid or an aldehyde or an ether or an ester. You guys remember the ones I'm talking about, right?
Yeah.
Okay. All righty. So, right, as of right now, that's it. Okay, that is my last day of review. Okay, so what I want, and this is something that is really going to tell me which one of you want to do well on the final. Okay. So what I would like to do is I would like to spend, so we've got Wednesday, Friday, Monday, Wednesday, right? So we've got 5, 6, 5, 8, 5. What will next Monday be? 4 and 7 is 11. And then 5, 13, right? And the 4 days we've got left. What I would like is for you guys to just go through, you could go through chapter 13's last day. It was one-sided. Or you could go through any of these cards. And I would just when you reach a topic you don't remember or that you need some brush up on, that is what I would ask a question on. Does that make sense?
Yeah.
Okay. Now, I don't care if you type them and email them to me if you want. I don't care if you just want to ask them over this, but I got to have, they're going to be student driven, which means I need more participation than the 2 or 3 of you doing all the talking. I mean, this is going to sound really, really terrible, but I am not worried about Tolman's grade. You know what I'm saying? I need the rest of you, the other 60 whatever we've got on here, to get your voice boxes warmed up. You know, maybe we got to do some you know, whatever's, so we can contribute here. Okay? But I need you guys to be ready to rock and roll on Wednesday with stuff that I can cover. Are we all understanding the words that are coming out of my mouth?
Yes.
Yeah.
Are we all understanding that?
Yes, we are.
Yeah.
Okay, so Wednesday is going to be student driven. We need to do well on this test. This is part of the whole 65% thing. It counts as its own, but it's still, you know, and as I've gone through it, you know, I look at it, you know, we could spend a day reviewing 13 if we had to. Whatever we got to do, you guys have got to be able to do this, okay?
Okay.
We good for today?
Yep.
Hey, Denton, guess what's on the wall?
What?
Guess what's on the wall?
Guess what's on what? Your name.
No, your face.
My face. Oh, it is up on the wall. That's funny. See like those pictures out of the 80s where they had like 2 different views, like a front view, and nobody knows what I'm talking about. Like they do like a.
I can't connect.
If the background of the projector wasn't white, like it wasn't saturated, you would have an infinite.
Oh yeah, there you go. That'd be funny. Yeah, that's all good. I'm cool like that, you know. Even if I'm the only one that
Cool.
hey, even if I'm the only one that thinks so, that's all that matters.
Do you still make jokes to yourself about your name on the wall even though we're not there?
Oh man, that's not very nice. I did. I will say, just give me 1 second. I got to show you guys something. So the other day, and yeah, I'm old. I had a funny right here. I'm on Facebook, and I literally laughed out loud at this meme. Okay. It says, on a scale of 1 to 10, how bad is your pain? And the guy says, pi. And the doctor's like, pi with a question mark. And he says, yeah, low level, but never ending. And it's just got funny. I literally laughed out loud to myself for like 5 minutes. And then like 10 minutes later, one of my friends responds and goes, hey, you've got to see this. I thought of you when I read it. And I laughed and I'm going, yeah, that's funny. Well, then I had a student actually reply back, a former student who graduated like 12 years ago. And he says, I think a better response to this would be pi question mark. And he goes, yeah. And he says, I would have said infinite and irrational. And I thought that was funny too. That was coming from a former student. So see, you know, it's all good. So anyway, I thought that was funny. I will leave this open until 10. If you guys have any questions, feel free to chime in, all righty?
Thank you.
Yep, see you guys. See you Wednesday.
Hey, Denton.
Yeah.
I think educational memes are barely memes at all.
Hey, maybe
It's fine.
Maybe you ought to just shut up. You like educational memes. I think they're funny.
They are, but like, it's too educational. Memes are meant to just be mind numbing.
Okay, so well, here's my new favorite one. It's got Kermit Frog standing at the window looking out, and it says, "It's supposed to be a student." And it goes, "Me missing my regular teacher because my new teacher kicks my butt." Get it? Their parents can kick. You don't see the humor in that?
Yeah, I see it.
Yeah. To me, that's funny. And I mean like funny, because yeah, I've had it out with my kid once this break already. Don't worry. Yeah. So, okay, see you guys.
Bye, Denton.
Stop.